Hi guys, we're going to be still applying that same property that says if a radius intersects with the tangent line at its point of tangency, a right angle will form, which this picture it is already given to you that happens because this radius hits this tangent line at the point of tangency C and forms that nifty right angle, as well as over here when this radius hits the tangent line at the point of tangency, bam, it makes a right angle. So this picture already kind of applied it for you, but technically I wouldn't have had to include those, and you should have already known that. Okay, but anyway, so it says quadrilateral CARD card. Board slapper. I love when my quadrilateral spelled and things. It's fun. But anyway, so quadrilateral CARD is a rectangle. So we can assume that bad boy is a rectangle, which means we can apply any of those lovely rectangle properties that you guys have already learned about. So keep those in mind. All right, so example 5 says encircle S. Remember, we name a circle by its center point. Technically, you guys, you can also see circle S could also be written like this. You might see like a mini picture of a circle with S. So if you see just this, that means circle S. Okay, I usually don't write it like that, but you can. All right, so circle S and circle R. So again, this could technically be circle with the little center point R. You could also write it like that shorthand if you want to. Mathematicians are usually lazy, so you can write it like that if you want. Anyway, so in circle S and circle R, C to the S is 36, D to the R is 20, that's a 20, and S to the R is 34. Find C to the D. Okay, so like normal, I'm going to label my pretty picture so that'll help me when I'm solving. So CS equals 36, so this whole thing right here, from here to here, that's a little curly brace even though it's struggling. C to the S is 36, okay, and then DR is 20, so this right here is 20. Okay, that's 20. Okay, and then SR is 34, so right here is 34. Okay, and we want to find CD. This is our angle. So I want to find this length right here. This is the one I don't know. Okay, so you're probably looking at this and you're like, Miss Long, I have no idea how to use this information to get there. Well, remember, in geometry, sometimes we have to look within shapes to find other shapes to help us solve. Okay, so that is an important thing. Okay, so looking at this picture, okay, if we know that this is a rectangle, what do we know about opposite sides in a rectangle or a parallelogram? Because guess what, you guys? A rectangle is a parallelogram. Okay, so since this is a rectangle, opposite sides are congruent. I knew you knew. You guys are on a roll like normal. Okay, so opposite sides are congruent. So if this is 20, that means that this piece is 20 of the whole radius. So the whole radius is 36, but that's 20. So if this piece is 20, if CA is 20, what would AS be if the whole radius is 36? It would be 16. And remember, guys, I did not say draw on the scale, so it's okay that this piece looks shorter than that piece. Okay, so since I don't have the words draw on the scale, that means you can't take anything for its word in the picture on how it's drawn. You can only take what it says about the picture. Okay, so that is 20 as well, so that might help me. I don't know, we'll see, and that's 16. Okay, also, since in a rectangle opposite sides are congruent, if I can find this little dashed line, which side of the rectangle is congruent to AR? CD is congruent to AR, so these two are congruent. So these two are congruent. Okay, and these two were congruent. Okay, so if I know this dashed line right here in my rectangle, then I will know CD. So, looking further into the picture, okay, we know that a rectangle, opposite sides are congruent, but since they're a parallelogram, opposite sides are also parallel. Okay, so I know that if this is 90 degrees, okay, I'm going to highlight some things. I know if this is 90 degrees, okay, and we know that these are parallel lines, so that means I can incorporate some of those nifty parallel line theorems we talked about. Okay, so let's see if I can figure out what this angle is right here. Angle RAS. So what shape are we seeing form right here? What letter do you guys see? Do you guys see the F? Do you see it? I'm going to zoom in. Do you see it? Whoa. All right, guys, and what type of angles are the F angles and parallel lines? They are corresponding angles, which means that these two angles, angles RAS and DCA, the relationship is they're congruent. So if angle, which you can't see it, angle DCA, okay, is 90 degrees, okay, which means that this other angle is also 90 degrees, okay, and that's going to help us when we're solving. So this is also 90 degrees, okay? Okay, so now I'm really trying hard either to find CD, which is what I want to find, or AR. Because if I can find AR, that means I can find CD. So let's see. Oh, sorry, I was trying to zoom back out, and I'm failing. All right. And please ignore the car alarm going off in the background. The demon cats are getting someone in my apartment. Sorry, guys. But anyways, so looking at the picture, we need to look within the shape to either find that bad boy or that bad boy. So do you guys see a shape within the shape that might help us? All right, let's see here. Well, what I spot with my little eye is this triangle right here. Do you guys see it? Okay, I'm going to use a different color to highlight that. If I can find my nifty highlighters. Here they are. Guys, so right here is another shape, which is a triangle. Do you guys see this triangle right here? And what kind of triangle is that? It is a right triangle. So I'm going to draw that right triangle down here because I'm confident that this right triangle can help me find side AR, which will then help me find side CD. I'm just confident about it. Okay, so I'm going to draw a mini version of that down below. All right. Okay. Okay, so I have A, S, and R. Okay, yeah, so we know that AR is congruent to CD because opposite sides of a rectangle are congruent. So I know that segment AR is congruent to segment CD, which means that their lengths are equivalent. So that implies, I can draw an arrow saying that that implies. This little symbol means that implies this. That little double-line arrow thing, another little math symbol you can learn about. So this implies that AR, the length of AR equals the length of CD. Guys, if we can find AR, we can find CD. All right, let me label my sides real quickly. So in this triangle, we have, this is 34, this is 16, and this side we don't know. But if I can find that side, that means that I can find CD. So we're going to get to AR. All right, so we have a right triangle. How do we find the sides of a right triangle? Holy hot dog, we do use the Pythagorean theorem. So I'm going to use the Pythagorean theorem to help me solve. Okay, so remember in the Pythagorean theorem, the two sides of the right angle are the little guys, or the A and the B. Okay, so these are the A and the B, and then the hypotenuse, the side across from the 90-degree angle, is the C. So these are the sides of my right angle. So I'm going to label one of them A and one of them B. It doesn't really matter which one I label A and B. All right, and then the side across from my 90-degree angle is my C, or my hypotenuse, or my hippopotamus. Another board slapper. I'm full of jokes today. But anyways, let's get going. So I know I'm going to have A squared plus B squared equals C squared. All right, so I'm going to fill in, I'm going to substitute in my values real quickly. So my A is side AS, which is 16. So this is 16 squared plus B squared, which I don't know, okay, which I'm going to call B squared side AR. So this is AR squared. Okay, equals C squared, which is 34. All right, we just have to solve for AR, which means we'll find CD, and then we'll be done, so you guys. All right, let's get going. So, let's see here. 16 squared is 256 plus AR squared equals 34 squared, which is 1,156. Okay, which I definitely didn't know off the top of my head. I worked out in advance. I'm not a math magician in that regard. So some of this stuff you do need to do by hand. Like when I originally did this, I did 34 times 34 by hand, and I did 16 times 16 by hand. So just saying, I didn't just know this in my head. But anyways, let's keep going. So I need to get AR by itself. So how do I move a positive 256 to the other side? I would subtract that bad boy on both sides. All right, which 256 minus 256 cancels and turns to 0. 1,156 minus 256 gives me 900. Oh, not 9,000. Sorry, 900. The demon cats almost got me. That car alarm. I knew that the demon cats are close because I heard that car alarm. All right, so now we have AR squared equals 900. All right, guys, we're so close. How do we undo a squared? What's the opposite or the inverse of a squared? It is the square root, and I'm going to square root both sides. Square root that thing. Bam. All right, which the square root of AR squared, these two will cancel each other out. So bam and bam. So that leaves me with AR equals the square root of 900, which let's think about this. What times what gives me 9? Okay, 3 times 3 gives me 9. What times what do you think will give me 900? It is 30. You guys just are on the same page as me all the time. Okay, so we know AR will equal 30. Okay, which that's very helpful because we know since AR equals CD, that means that CD will also be 30. Holy hot dog, you guys. That was exciting. I'm sad though, because the problem just ended. I don't like when the problem ends. Okay, so that means that CD is 30. And since I have all this blank space, might as well draw like a bunch of cats. Don't waste that blank space. Yay! Gonna draw a little kitten family over here. Alright guys, we have 3 cats right here, which means we had a triple blast. So I hope you guys enjoyed this problem.